So this is a nice problem that combines elements of identifying graphs and starting to get used to the idea of inequalities in a graph. So we're told there are two equations here. One of the equations is y equals negative x minus 1 to the fourth power. And the other equation is y equals 1 minus x. And we're told that they're graphed on this plane, although we're not told which one is which. And they want to know, where is this inequality satisfied? Where is the first line less than the second line? So it would help if we could identify which line was which, wouldn't it? Well, let's talk about one of them. Y equals 1 minus x. You can see if you rearrange this, it doesn't take much work to put this in the form negative x plus 1, right? I just switched x and 1. And that shows me I have a y-intercept of 1 and a negative slope. There's my y-intercept of 1. Here's my negative slope here. So I know that this line, let me draw this right here. This is y equals 1 minus x, that negative diagonal. And that means that the line y equals negative x minus 1 to the fourth power is this strange upside down U shape, which perhaps you already knew how to graph a fourth power polynomial. That's fine, but it's not necessary to understand how to graph that one if you can identify the linear one right here. Okay, so what I want to understand now is, how do I satisfy this inequality? And let me direct your attention up here. This is what I'm talking about. I need to know where the first line, the curvy one, negative x minus 1 to the fourth power, is less than 1 minus x. Where is that condition satisfied? So let's get some space to draw in here. Here's what I'm saying. Where is the curvy one less than the straight one? Well, all this area that I'm shading in right here. Okay, this is all going to be true out forever in that direction. And then you see it's not true in this stuff. In this area, the curvy line is greater than the diagonal line, so I don't want that. But then over here, looks like it's good again, because the curvy one is below the straight one. So now, where is this satisfied? For what values of x is this satisfied? And if you look down here at your list, we have a bunch of x values, and we just have to figure out which one is describing the shaded situation that I have above here. Well, it's certainly not between 0 and 1. Okay, that's the opposite of what we want. And x equals 1, x equals 2, that looks appealing. This one right here, that looks appealing because we see something happening at these points. But those are intersection points. It's not an inequality that I have right there. So it's appealing, but that's not what we want either. We want this one, the fourth down on this list. We want x less than 1, and we want x greater than 2. Those are the two regions that I'm talking about.